All right, so sometimes what happens is sometimes you'll get a series like this with a, n's, and whatnot, and this will turn out to be very difficult. And often the difficulty lies in some sort of strange oscillating sign in here, some pattern with the signs that makes it hard to either apply the integral test or some of the other tests. So sometimes the difficulty comes from the sign patterns. So for that we have some good medicine. When the difficulty comes from the sign patterns, try this. Why don't we look at just the absolute value of the series, version of the series. Just keep everything positive. Just keep adding everything, all the terms, instead of adding some and subtracting some. If that one converges, well, for sure the other one's got to be smaller because some of the stuff gets subtracted. So when the difficulty arises from the sign patterns, forget about them. Just do the absolute value. And here's what we can conclude. If the absolute value version of the series converges, then the original one must also converge. Okay? And then when that happens, we have some special terminology here. We call the sequence absolutely convergent, because both it converges in absolute value and without the absolute values. We say it's absolutely convergent. It means it converges really, really fast. Well, this one would, if the absolute value converges where everything is being added, and this one, some of the things are being subtracted, of course it's going to converge much faster. Anyways, sometimes that doesn't happen though. So when this one converges but the absolute value doesn't, we call that conditionally convergent. Okay, so some terminology. When both of them converge, the absolute value, we call it absolutely convergent. When only one of them does, but not the one with absolute values, it's called conditional convergent. Here's how you might use that in an actual problem. So suppose you've got a problem such as this one, where the sign pattern is a little bit tricky. If you study the sign pattern on this one for 10 seconds, you realize how it goes. It goes like this. For 1, when n is equal to 1, that would give you 2 here. So that would give you negative 1 over 1 square. And then the next one, for n is equal to 2, that would cancel. That would give you 3. So that would give you negative 1, 2 square. And then, but then for 4, sorry, 1, 2, 3. For 3, this will give you 4. So this will be an even number, so it'll give you 1 over 3 square, and so on and so forth. It basically goes negative, negative, positive, positive, negative, negative. So it's not exactly, of course, over some stuff here. So it's not exactly an alternating series. It has some sort of alternating pattern, but it's not plus minus plus minus plus minus. It's minus minus plus plus minus minus plus plus. That may be difficult to deal with, but if we use this idea, we may be able to get some nice results. We're going to try to show, forget about the absolute values, we're going to try to show just the absolute value of the, forget about the signs, we'll show that the absolute value converges, and then we'll be done. Alright, so we check. What does the absolute value look like? Absolute value version of the series? Well, that would look like this. Forget about this piece right here, the one that's causing all the alternating signs. You can forget about it. Here we go. Sorry. Forget about the alternating sign business. That's the numerator here. Really, the absolute value of the sign looks like this: 1 over n squared. And this one, of course, converges by, well, it certainly converges by the integral test. You could do the integral test on that one and you'd be done. And this is the absolute value version of that one, where nothing gets subtracted, everything gets added. Therefore, we're done. That's it. That's all you got to do is check that the absolute value converges. The other one must converge as well. And we say that AN also converges, and of course we call this absolutely convergent. Okay? So the point is, whenever you can't show something converges, show that it's absolutely convergent, and that's even better. Okay? Alright, that's it. We'll see you guys next time. Peace.